You will learn how to enhance the performance and availability of your DNS on AKS by using local DNS. By default, the AKS clusters will rely on CoreDNS to do domain name resolution. CoreDNS is installed into the AKS cluster as a system component, and it will resolve the internal DNS names as well as the external names. Through kubectl get pods from the namespace kubesystem, we can view the pods that were installed by CoreDNS. Mainly, we have two pods acting as the DNS server and another pod that will help autoscaling the CoreDNS. In terms of services, CoreDNS is available within a service that is called CubeDNS. It's most of the time it's exposed through the IP address 10.0.0.10, but you can change that if you want to. So through CoreDNS, we can resolve external and internal domain names, like for example here microsoft.com. Note that here the address that will be used here is the same IP address of the CoreDNS. CoreDNS is installed into the AKS cluster with at least two replica. These two replica could live within two different virtual machines or two different nodes, and these two nodes could be within two different availability zones like AZ1 and AZ2, for example. And then any app or pod that wants to resolve domain name, and it will use that one of the two instances of CoreDNS. This design works well, but when you want to optimize at the millisecond level the performance of your DNS server, then this design will pose a problem actually. Because here, if your pod is within another availability zone and it's tried to reach the core DNS that lives in another availability zone, then this means that here this will add latency to your request. And in addition to that, in AKS, when you use the service meshes or the health checks and the inter-service calls will generate thousands of DNS queries per second. And per the nature of Kubernetes, the services and the pods will frequently change their IP addresses, which requires constant DNS updates and cache and validation. Luckily, CoreDNS can autoscale, but the autoscaling mechanism here does not rely on the CPU and memory usage, and it does not rely on the HPA, the horizontal pod autoscaler. Instead, actually, it will rely in a pod that is called CoreDNS autoscaler. The role of this pod is to autoscale the number of instances of CoreDNS based on number of cores in your cluster and the number of the nodes. So each time you have that number go higher, then a new instance of CoreDNS will be created for you. By default and at minimum it's 2, but that number might go 3, 4, 5, and so on. The issue that might happen here is that you might have a small cluster in terms of number of nodes and virtual cores, but you might have also at the same time some applications that sends lots and lots of DNS queries to CoreDNS. CoreDNS in this case might struggle to respond, and we might have lots of latency. Those challenges impose us to have a better design and a better architecture, and that's the promise of local DNS. So at the base, we'll still have the core DNS installed as it is today, but we'll add another DNS server at the node level. On each node, we'll go to install a local DNS like you see on the schema right here. So that each DNS query will be served by the local DNS on the same node. This means that this app right here does not need anymore to go to the other instances of core DNS that might live in another availability zone. It will use the already available DNS server within its own node. So the traffic here is way much more faster in terms of performance. This design will also enhance the availability of the DNS because local DNS here will add redundancy to core DNS. So when I don't have a core DNS available for any reason, then the app actually will rely on its own local DNS. Unlike core DNS, which is installed as a pod inside the cluster, local DNS is installed as a systemd program within the node. So you don't see it as a pod running. So we keep core DNS and local DNS to work together. How they work together? Let's say here we have a pod that wants to resolve a specific domain name. So the DNS query will be sent first to the local DNS. If the local DNS have the answer, then it will answer directly. If it doesn't, then it will forward that query to the core DNS through the CoreDNS service name. CoreDNS, if it cannot resolve that domain name, then again it will use an upstream DNS server from the outside and then gets the response. The response will be sent back to the local DNS. Then local DNS will go to cache that response within its own system, and then the pod will get that resolution. So here for public DNS names, the local DNS actually have two options for forwarding or for resolving that public domain names. Either it relies on CoreDNS, or you can change that behavior by a policy where local DNS can in its turn go directly to the upstream DNS. So the same way we can configure CoreDNS using a config map, local DNS could be configured through a JSON file that looks like this one I have available right here. And in this file, we can configure actually the internal names as well as the external domain names. And it's worth noting that also local DNS could be enabled not at the cluster level, but enabled the node pool level. It means that for each node pool, I need to enable local DNS independently if I want to. So then I can enable it on some node pools and disable it on other node pools, for example. And also for each node pool, I can specify a different DNS configuration. So note here, to enable it, we just use az AKS node pool update, and then we pass parameter name local DNS config, and then we specify the local DNS config.json file, which is this file right here. Now it's time for a demonstration for local DNS in AKS, where we see how we can resolve external domain names using the local DNS server. In this demonstration, we'll learn how to enable local DNS in an AKS cluster and then use it to resolve internal and external domain names. The source code for this demonstration is available within this GitHub repository at AKS course under the folder 810. So here you will find the README file that contains all the instructions that we'll go through today. I have already created an AKS cluster within my Azure subscription. It lives right here. And then for the instructions of this demonstration, I show here how I have created the cluster using the command line. So note that here during the cluster creation, I didn't enable local DNS, but we'll enable it later and we'll see how to do that. So I started here by checking the nodes of my cluster. We see we have 3 nodes, and then I checked the pods of my cluster, and we can see here clearly the 2 pods running CoreDNS server in my cluster. And then for the services, we can see the CoreDNS service that will forward back to the CoreDNS. And then from here, I've installed an Nginx sample pod, and then I've installed DNS utils so that I can use nslookup command from inside that Nginx pod. And then I've tried here nslookup microsoft.com, and here I get the response coming from the CoreDNS server, which is running on address, or which its service actually is running on address 10.0010 on port 53. And here we get the domain name resolution for Microsoft.com, which have multiple IP addresses. So now we'll go to enable local DNS on an AKS cluster. And as we said, we enable it per node pool. So we take our node pools one by one, and then we deploy in each node. Here in my cluster, I have one single node pool. That is the system node pool. So I'll go to install it there. And I do that here by running the command az AKS node pool update, and then specify the name of my node pool, the name of my cluster, the resource group name, and then I specify here local DNS config, and I specify the local DNS config.json file. That's the file that I have right here. I've taken from our Microsoft official documentation. You can find an example right there. And I've made some changes right here, like specifying the query log to log in order to be able to log all the queries going to local DNS. So you'll note that here for this file, you have actually 2 main sections, VNet DNS overrides and CoreDNS overrides. Both will describe how you can do internal domain name resolution for cluster.local. So for any service that you create in your AKS cluster, you can do it right here. And for the dot here, that's the section for the public domain names. Once that's deployed, actually when it will be enabled, all the nodes of your node pool will be restarted, because we would have actually here a re-image operation running on all the nodes of that node pool. So make sure that your applications are compatible with that restart of the node pool. Once local DNS is enabled, we can verify the local DNS functionality, and there we can reuse our Nginx pod, which have NSLookup installed, and we try here to resolve a domain name like an internal domain name for Kubernetes.default, which is the service name for the control plane of AKS. So let's try that on my command line right here, run that, and yes, we get here almost the same response. So we get here the resolution going to 10.001, which is, as I said, the service name for the control plane. So if I do here control get svc, you see here that's the IP of kubernetes.default.svc.cluster.local. Great. Note that here there is a difference with local DNS. Local DNS is served on 10.0010, but here local DNS will be served on this IP address 169.254.10.12. That IP is exposed within the node of the cluster. Let's try now with a public domain name like Microsoft.com, for example. And yes, here we get the same DNS resolution using the same IP address for local DNS. And this IP actually is the same for all the local DNS servers. So all pods, even they live within different nodes, they will all use the same IP address right here to access their local DNS. Like CoreDNS, local DNS will also expose some Prometheus metrics that will be available on the node IP address and on the port number 9253/metrics. So if I try right here to query that endpoint by specifying the node IP address of my AKS cluster, one of the nodes, then add that port number /metrics, then here you can see some metrics in the Prometheus format. And actually we have lots of metrics right here available. So then you can export those metrics to a Prometheus Grafana and visualize them.